All right. Hi, everybody. Oh my gosh. Okay, so I will say this just to start things out. I am super excited for this LinkedIn Live, but truth be told, I am slightly intimidated. The amount of like feedback and the amount of people pre-registering for this, like, it's blown my mind. They're all over the world. Like, I see people that have registered from Singapore and Germany and Sweden and I think India and of course all over the US. So I mean, I think that just goes to show the interest level in upscaling and learning more about lithium-ion batteries. So hey, if you guys are from all over the world, shoot it in the comments. I love to see where everybody's located. And of course, throughout this entire LinkedIn Live, any questions that come up or you want to learn more about, shoot them in the chat and we'll try to get them in as soon as we can. So a little bit of background about me. My name is Ashley Taylor. If you don't know me, I am the founder of Green Tech Resources. We are an organization that helps growing companies in the world of sustainability scale their workforce by finding them niche technical talent. So we have been doing these LinkedIn Live kind of back to reality and tech and green tech. We've done a couple now, I just think this is the third. But we've been really focusing, the last time we talked, the first one was about compensation and compensation expectations, especially oriented for the US. But the last one was about upskilling and just the importance of looking at the industry and where the industry is going and making sure that you're aligning and your goals and your skill sets. So in that LinkedIn Live, you can go watch the recorded version, by the way, if you didn't see it. But in that LinkedIn Live, we talked a lot about the different jobs that were going to be becoming more and more necessary. So if you were looking to pivot your careers, that's, look into what's going to be needed. But then also, how do you get your skills in alignment with that? So we talked about some specific strategies where you could go through. And one of those strategies is training. So after this LinkedIn Live, I got this amazing message from Dr. Frank Richter. He is the owner, CEO, and founder of a company called Greenectra. And he reached out and he's just like, hey, Ashley, I saw you at your LinkedIn Live. I think we have a lot in common. Can we jump on a call? So we did, and it was just an amazing conversation. We talked a lot about his company, Greenectra, which we'll go into even more so in a minute. But just like he has developed this entire amazing training program, multiple training programs actually, that are oriented specifically for battery engineers and battery engineering teams. So from an introductory phase to, he has modules on testing and safety, and he has even courses on electrochemical. He's absolutely amazing. So I was like, after this talk with him, I was like, look, this is amazing. I need to share this with my network, and I need people to know that your company exists, and that's kind of where this kind of spun off from. So I'm gonna bring in Frank here. Let's see. Here we go. Hey, Frank.
Hello, and thanks for having me.
Yeah, absolutely. So I wanted to just give a brief introduction on Dr. Franks, because you're probably like, if you haven't heard of him before, you need to hear of him. So Dr. Frank, he is literally a trailblazer in lithium-ion batteries. He has a Ph.D. in chemistry from NTNU in Norway. He's literally dedicated his entire career to revolutionizing battery system development. And he's done it cross-functionally in different organizations and industries, all the way from like automotive to maritime and much, much more. So he's now, as I mentioned, the CEO and founder of Greenectra, a leading coaching and consulting company specializing specifically in lithium-ion technology. So he is basically just a really smart dude and way smarter than I am. So I am so honored and excited to get to talk with him a little bit more and get to know him a little bit better. Also, if you're interested in learning a little bit more about his courses and the courses that he has, I dropped a link in the comments about an hour ago. So feel free to click the link and check them out. I will say this, one super exciting thing on the topic of his courses, he literally just dropped, and when I say just, like within like the last 12, 24 hours, his newest course focusing on battery lithium-ion training. It's called Bad Excel. Am I saying that right? Yeah, okay. And it's specifically focusing on that. And it has 3 different modules. It's the operations, it's the testing, and it's the safety, all oriented for the US. So one of the things I will say I love about Dr. Frank and what he does so exceptionally is he's incredible at explaining things and having analogies for things. So he's that, and then also all of his courses, most of them are hybrid model, and he makes them very personalized because he only allows 15 people to join max. So if you're interested in that US course, like I said, it literally just dropped. I think that registration closes on the 4th, but if it gets full before that, then but be sure to check that one out too. I think that's super cool, and it's in US time zones and everything as well. So with that being said, I mean, Frank, go ahead. What did I miss? Please go ahead and introduce yourself.
I must say that was the longest and nicest introduction I ever got in any of online meetings. So I'm very happy about it. Thank you very much. And once again, it's a pleasure being here today.
Yeah, absolutely. So one of the questions I had for you is, obviously you had like a very technical background. So I think today we're going to go through, like I said, a little bit. I had some questions for you about just your program and your background, but then also I know we had some technical questions that were submitted. So I want to get to those too. So we'll try to keep things moving. But I was just super curious, how did you go from, being this super tech guy to evolving into this training and coaching aspect? What was kind of the evolution of your career and what led you there?
Well, basically, I could say it. I always was motivated in teaching. I like to explain stuff, and there was a big need in the industry. And we had it in my old German company, and they said, "Hey, Frank, you are our battery experts. It's very difficult to get people with battery-related knowledge. No people are in the market right now. So what you can do is you can get, for example, students from technical disciplines like electrical engineering, mechanical engineering, you name it, right? And give them some extra education. Or you can reskill personnel which you already have. So basically, the first step towards this was more or less the creating of courses for our own future or actual personnel within the old company in Germany. So basically, Frank, you are our battery expert. We want more people with battery knowledge. Could you make some courses? That was basically the start, yes.
Okay, well, that makes sense. I mean, it is such a glaring need. It's a topic of conversation that I actively have with different organizations and OEMs on there's this talent gap that's needed, and how are we going to fill it? So I think you saw a need and went for it, and obviously you have the know-how and the background to make it happen. So when you look at the industry, what are the specific gaps of skill sets that you see in battery development?
Well, I would not, so to say, talk too much about the skill set itself, but it's more like, let's have a look at the battery development project, right? We have all these different disciplines. You have mechanical engineers, you have electrical engineers, you have computer scientists, guys who are able to program a battery management system. Basically, different people and different backgrounds working together on one project. But from my experience, it's quite difficult for the electrical engineer to communicate effectively with the mechanical engineer and the other way around. So there's always like this one guy in the center. It's the battery expert, and he is usually organizing and so to say having the lead in this development, which is not nice if you are the battery expert, because then you're very overloaded with work. So basically, if we talk about skills, it's just basic skills, basic battery knowledge for mechanical engineers and as well for electrical engineers, as well as for programmers. So let me name just one example. If you look at the aging of a lithium-ion battery, we know that as the battery ages, we can see an increase in internal resistance, we can see loss in capacity, and we can also see power loss. So that's quite interesting for an electrical engineer. But these are obviously also parameters which a programmer who programs the BMS must be aware of, right? And then you have the mechanical engineer, and let's just stay with aging. We know that as the battery ages, specifically when we use graphite as one of the electrodes, we have a swelling effect. And the battery basically gets a little thicker. First of all, during charging and discharging, it breathes, right? But also as the battery gets older, it gets a little thicker. So this is something that mechanical engineers need to be aware about. And then we have people, for example, in sales teams, and they are in the meetings, for example, with the battery manufacturer. And the battery manufacturer tells them, now let me just make something up. We exchanged one part in the production process, and therefore we have, let's say, a better aging behavior. We lose less capacity, let's say 5% less within the first 5 years, just to make something up. But then you need the people to be able to ask good questions and really challenge, so to say, what you're told in these meetings. And people should be, so to say, also able to evaluate the battery production, and so to say, there's also other fields. If you look at the testing engineers, if you are like a small company, you usually carry out the battery testing by yourself. You build your own test stand, and basically you have to plan the whole thing by yourself. But if you're like a big company, it's very common that the battery manufacturers actually carry out some of the tests for you. So what you get are battery test reports, and basically you define the battery test specifications, and then you get some test reports, and then you basically double check, does this test report fulfill the specifications? But in most cases, that's not really the case. So, and then you need someone who is educated enough to be able to say, hey, this is not really 100% according to the specification, but this is still okay. Maybe this test we have to redo, this whole test series we have to redo. I've seen a lot of test reports, and I'm not naming any manufacturer, of course, but I can tell you that very often they are not according to the specifications which you actually give. And then you need really someone educated to be able to really qualitatively judge this. Not just look, do we get what we ask for, but if it's not 100%, to be able to judge, so to say, what's the next step, basically. And there are, And finally, there are people, maybe I can mention this, if you look at the total cost of ownership or life cycle costs of a whole battery system, this is also a thing for sales and higher management. They should be aware of, at least to understand the technology to a good extent, to be able also to ask, so to say, the battery manufacturers, for example, good questions, but as well as to ask module manufacturers, systems manufacturers good questions.
Absolutely, absolutely. There's so many different, I never even thought about salespeople. Of course, they need to know what they're doing as well. But yeah, there's that battery. I know that battery expert, I was just talking to one of my friends in battery engineering just the other day, and he's like the battery integration person. So yes, her like trying to manage all these different people and everything, as you said. And if everybody just had a little bit more knowledge, it would go a long way. For sure. Cool. So I know, like, I think that people are here for the technical stuff. So obviously you just hit on some, but I want to just jump into some of these technical questions that were submitted ahead of time. As I mentioned, if other people have other questions for Dr. Frank, throw it in the comment section, and we'll hope to get to it. But I will kick things off. Okay, so the first question was, lithium-ion batteries can be charged and discharged again and again. But why do batteries need to be exchanged at one point?
Okay, so basically, I mean, obviously it's true that we can charge and discharge batteries again and again, but so to say, the discharge process and the charge process, that's not 100% what's actually going on in the battery. It's like close to 100% what's going on. I want to say that there are some reactions which we call side reactions, reactions that we don't really want to happen, but which happen to some extent. And some of these side reactions, for example, consume lithium, which is the reason for capacity loss over the lifetime of a battery. So at one point, you have lost too much capacity. And I'm not going too much into the aging yet. Now it would be we can talk for a very long time about aging, but if you also think about the increase in internal resistance, at one point you have a pretty high internal resistance, and which means if you have a real high current going through a system, you will have a lot of heat development, and maybe your cooling system is not dimensioned good enough at one point. I mean, right? So to say, you plan a project and you say, hey, up to this point in capacity loss and internal resistance increase, our system is dimensioned. We have the cooling for that. We consider all other factors, but at one point, so to say, it's out of what you originally planned. And that's why you should exchange it at this point.
Got it. Okay. So if batteries lose power, what would that mean that like an electric car loses acceleration power as the battery gets older?
Yes and no. So
Okay.
the battery loses power due to the internal resistance increase. There is a power loss, and for the car battery, that means you could say it's a loss in acceleration power. So that's the yes part of the question. No part of the question is that you don't really feel it, because car manufacturers are smart and they, so to say, they limit the battery system in the beginning of its lifetime to act like it's an already older battery. So you don't get the experience of power loss during the lifetime.
Interesting. Okay. Cool. Thank you. All right. Another question that was submitted here. Can lithium-ion batteries be recycled? The lithium must be quite valuable.
Okay. Well, if you look at the market at the moment, at the situation, we have recycling in place. Yeah. So the mostly it is pyrometallurgical and hydrometallurgical recycling. When you do hydrometallurgical recycling, you get a little bit more of material, right? But you also have to clean the water. So it's a little more, it's not really feasible for a lot of, so to say, scenarios. You mentioned that the lithium must be quite valuable. There are new recycling technologies that actually can recycle the lithium. But with these traditional recycling technologies, pyrometallurgical and hydrometallurgical, it's not really possible, at least according to my knowledge. But there are no now newer technologies. I was at a recycling conference 3 or 4 months ago, something like that, and there was actually a company who had some new technology who claimed that they can actually recycle the lithium as well. So I think, but I'm not really sure if this is now lab phase, if this is I mean, and how much time it takes to be like an industrial, economically feasible use case. That I cannot say. I mean, I actually don't know if the company could predict that by themselves.
Absolutely. That's a good answer. I also know that there's a new company here up in the US, Redwood Materials. They're doing some really amazing things in regards to battery manufacturing. I, again, am not the technical person that knows them all, but I know they're doing a lot of cool stuff too in that regard. So cool. All right, we got one more that was pre-submitted for us, and then if anybody else has anything, throw it in. Okay, I saw that lithium-ion batteries have different voltage. Why is there a difference?
Okay, that is I could say it's a very easy to answer question, but it can be very complex very quickly. So first of all, each battery has two electrodes, right? We have a plus electrode and a minus electrode. We have a cathode and we have an anode. And these electrodes have different electrochemical potentials. And basically, the difference in between these electrochemical potentials of the electrodes, that's the voltage in our battery. So now we could ask, like, what is an electrochemical potential? That's, I think, a question that may come up. And I like to compare it. Sometimes we have this question during the coachings as well. So if we look at Mount Everest, right, we know the height of Mount Everest. It's 8,848 meters. So, but why can we say it has that height? Because we define 0 meters at the sea level, right? We need to set the zero somewhere. And with the electrochemical potentials, it's the same. We need like a definition for the zero. And the zero within electrochemical potentials, it's actually what we call the standard hydrogen electrode. And I will not go into details, but very easy speaking, if you take a voltmeter, you put one electrode to the standard hydrogen electrode, which is a very complicated but standardized setup, and the other part of your voltmeter you could connect to your electrode of interest, then you will get like the standard chemical potential of this material. So, and then materials have different voltages towards the standard hydrogen electrode. And basically, the difference in these materials is then the electrochemical potential of the battery. So, but this is only one point. So, I mean, we have different voltages because of the different materials, but we also have different voltages. Voltage of a battery, for example, is different for an empty and it's different for a charged battery. And then again, voltage changes as a function of temperature as well. So there are many factors that actually affect the voltage. But I think what the person who asked the question, what you usually see is like nominal voltages of different battery types. And then we have LFP batteries and we have NMC batteries. There are still some LCO, just different, so to say, chemistries. And all of them have different nominal voltages, which you could understand like an average voltage between the charged and discharged.
Got it. That's, yes, like you said, it's simple, but not so simple either. So it makes sense, definitely. Cool. Well, I don't see any. Okay, Arturo says it can be possible to replace lithium-ion batteries by using lithium capacitors, as they can be cycled way more than lithium-ion batteries with no degradation. I think that was just a comment. And then I have another question here. Why is it necessary to do active paralleling in battery packs with multiple parallel cells? How does it fusing help to avoid circulating currents?
Okay, I now see the comments. Let me just read this very slowly again for myself. Could you specify what you mean with active paralleling? Because I don't think it's about balancing, because battery cells in parallel automatically, whenever two cells are in parallel, you don't need any balancing because they even out automatically.
Well, we'll keep our eye out here for his or her response. I think it just says LinkedIn user on my end here, but as we're waiting for that, there's one big thing I wanted before people jump to get to is, I know, so Dr. Frank is like super just passionate about enhancing people's learning and upskilling. So while I was talking with him, we're like, I don't think this LinkedIn Live will be enough. You know, it's really hard to deep dive into technical stuff on these things. So what he came up with was doing a free 45-minute webinar. So he's going to do one, and I'm going to help support on this next upcoming Tuesday at 2 p.m. Eastern. So it's going to be basically an overview of technical vocabulary and different challenges specific to lithium-ion batteries. It's going to be super helpful we talked about that collaboration earlier, so it's going to be super helpful for any team that operates around battery development, like the mechanical, the electrical, the software, all the sales, if you will, any of those teams. It would be a really, really impactful one to join. So that's going to be via Zoom, so it can be even more interactive than this. We can dive a little bit deeper. Right as soon as this is done, I'm going to drop a link to the Zoom or to the webinar registration in the link or in the comments. So that way you guys can sign up. You do need to sign up for it because it is going to be a Zoom, and we'll send you the Zoom link for it. So would love to see as many people there as possible. You'll have an idea and get a feel for how Dr. Frank teaches, and then also his interaction and collaboration. So I did just want to say that real quick, but I noticed we got an answer. So using cells in parallel to isolate defective cells in parallel.
Yes, I want to comment on that. Maybe, I'm quite easy to find on LinkedIn, and I would ask the user. I only see LinkedIn user on the chat, so I do not see any name. Please contact me and reach out to me, and I promise you, I take some time, and we have a discussion about it. No problem.
Awesome. Sounds good. Well, I am just so thankful. It was so serendipitous that you happened to find our upskilling event that a couple weeks ago. And then I'm so thankful that you reached out and we got to have this conversation, and I got to share you and your resources with my neck of the woods and my network. So I'm just so thankful for your time and getting to know you, and you're just an incredible person. So thanks again.
Thank you very much. It was a pleasure being here.
Yeah. All right. Bye, everyone.
Bye-bye.